What is a gearbox? Well, let's say these are the gears and this is a box. And now put these gears inside the box in such arrangement that this system can change or modify three things: output speed, output torque, or at least output direction. We can call it a gearbox. Also, gearbox can be variable ratio gearbox, like in car transmission, in bicycles. We can change the gear ratio by shifting gear lever to speed up or speed down. Also, gearbox can be indexing gearbox, indexing the table in steps. And today we will master the most used gearbox for industrial motors, like Planetary gearbox, Worm gearbox, Bevel gearbox, Spur gearbox, and Helical gearbox, and how to choose the right gearbox between all these gearbox as per the machine or as per the given specification. And end of the video, we will also conclude that as a mechanical design engineer, how we should start thinking, how we should start taking steps to finalize the gearbox specification in a machine design. So let's start with very basic revision of university study. So before gearbox, what is the gear? We can say gear is a mechanical component with tooth edges. Gear teeth can be on outer surface. Gear teeth can be on inner surface, or gear can be flat, and we can call it rack. Gear teeth shape can be simple, straight parallel with the gear rotational axis, and we can call it spur gear. Gear shape can be complex too, at some angle to the gear rotational axis, and we can call it helical gear. Also, gear teeth plane can be itself at an angle on a conical shape, and we can call it bevel gear. Also, the teeth can be in form of a screw, and we can call it worm gear. And there is many more type of gears like a spiral bevel gear. But the main thing is the gear teeth should be interlocked with the other gear teeth to transmit the power. Otherwise, a single gear is not much meaningful. And the arrangement of two or more gears which mesh together and able to transfer the motion and power one to other, we can call it gear trains. And if the arrangement of gear is a spur gear, we can call it a spur gearbox. And if the gear arrangement are bevel gear, we can call it bevel gearbox. Likewise, if the gears are arranged in sun and planet arrangement, we can call it planetary gearbox. Very simple, so far so good. Now I want your closer attention. Let's say we have these two shafts, shaft 1 and the shaft 2 fixed with the bearings. And we have to transfer the motion and power from shaft 1, driving shaft, to the shaft 2, the driven shaft. And to do that, here I am putting the gears on the both shafts. Simple spur gear. But I have choose the different size of gear. Gear 1, the driving gear, have number of teeth 100. And the gear 2, the driven gear, have the number of teeth 25. But teeth size are exactly same. So they can interlock and move with each other. But there is a thing, when I am rotating any one of the gear, the smaller gear moves faster and the bigger gear moves slower. Why? Because on the smaller gear, the total number of tooth is 25 and it covers complete circle, complete circumference of the gear. But on the bigger gear, the same 25 number of tooth cover only 1/4 of complete circumference of the gear. Means in a gear trains, a gear rotational ratio depend on number of teeth ratio. And we can call it gear ratio. And we can calculate the gear ratio by number of teeth on driven gear divided by number of teeth on driving gear. And here the number of tooth on driven gear is 25 and the number of tooth on driving gear is 100. So the gear ratio between these two gears will be 1:4. So when the bigger gear is taking 1 revolution, the smaller gear completes 4 revolution. And vice versa, when a smaller gear completes 1 full revolution, the bigger gear completes only 1/4 revolution. Means the driving gear velocity is 4 times of driving gear velocity. Means the velocity ratio of the gear trains is inverse to the gear ratio of gear trains, and we can write it speed of driving gear divided by speed of driving gear equal to driving gear number of teeth divided by driving gear number of teeth. And this is why the high gear ratio gearboxes gives the slow speed output and low gear ratio gearbox gives the high speed output. And now the most important thing, as we know, the gearbox not only transferring the motion, gearbox also transfer the power, the torque. And we also know the power is rate of doing work or energy expend in a unit time, joule per second. And here the time is fixed for the both gear rotate at the same time. And as per the law of nature, the total amount of energy do not change, energy only change their form. So here the energy is constant, means the power will remain constant for the both gears. Means the power at input shaft at driving gear is equal to power at the output shaft at the driving gear. And as we know, the power is equal to torque multiplied by rotational speed. So we can write it, the torque of driving gear multiplied by speed of driving gear equal to the torque of driving gear multiplied by speed of driving gear. And if we will rearrange the equation, it will become ratio of driving torque and driving torque equal to ratio of driving speed and driving speed. And if we will combine with the gear speed and gear ratio equation, we can get this equation. Oh my god, it's confusing. So just for simplification, the gear train speed ratio is inverse to gear train torque ratio as well as number of gear teeth ratio. So what are the main purpose of a gear arrangement or a gearbox? Number 1, the gearbox changes the speed ratio between input shaft and output shaft, either increase or decrease the speed ratio. Number 2, when gearbox increase the speed ratio, torque decreases in the same ratio. And when the gearbox decreases the speed ratio, the torque increases in the same ratio because power remains constant. For example, let's say we have 1 HP motor and the motor speed is 1500 RPM and the torque is 5 Newton meter. And we have to add a gearbox of ratio 1:10 at the motor output. So the speed at the gearbox output will become 1500 multiplied by 1/10. So it will become 150 RPM. And at the same time, the torque will become 5 × 10. Torque of the motor multiplied by 10 times. So it will be 50 Newton meter. But the power will remain same, 1 HP. With gearbox or without gearbox. But this is a theory. In actual, the gearbox cannot transfer the total amount of power as it is. Some amount of energy losses because of teeth friction, which converts in heat energy and some sound energy, noises. And we can specify these losses in terms of gearbox efficiency. In normal gearboxes, we can get 80 to 85% efficiency, and in precise gearbox, we can get the efficiency up to 95%. And the third purpose of the gearbox is just to change the direction of motion. Like a worm gearbox or a Bevel gearbox changes the shaft direction at 90 degrees. And the fourth purpose of a gearbox can be just to change the direction of rotation. Like here, the input shaft is rotating in clockwise direction and the output shaft is rotating in anti-clockwise direction. So if we want the same rotational direction, we can add one more gear between input and output shaft gear, something like this. And let's put this gear train into a box well fitted with bearings and pour some oil. That's it. That's the gearbox, Spur gearbox. Also, the Spur gearbox can be in multi-stages. So as we seen, the Spur gearbox is the simple design, and because of the simple design, their manufacturing cost is low. Straight teeth manufacturing is easy. Also, the Spur gearbox is easy to assemble. So if the Spur gearbox is the simple and cost effective, then why we need other type of gearboxes? The answer is Spur gearbox have so many cons. And to understand the cons of the Spur gearbox, first I want you to understand the two important terms related to the gearboxes, so it will be easy to understand. And the first term is the backlash. And in general, we can say the backlash is the play between gear train teeths. When the two gear teeths are interlocked with each other, there will be some gap in some micron, and this gap is the backlash. And this backlash adds inaccuracy in motion transfer. And at the same time, the backlash is necessary for the two regions. The first obvious reason is the backlash is necessary to assemble the gear teeth together. Also, the backlash is necessary to movement of gear. And the second reason is the when gear moves with load due to applied torque and high gear ratio, the gears beating off each other hardly, and in result the temperature raises and the gears thermal expansions happen. And the backlash is necessary to compensate this thermal expansion in gear teeths. And as we know, the gearbox do rotational motion. So we measure the gearbox backlash as an angular backlash in degree. But the degree is the bigger unit for the measuring of backlash in a gearbox. So we denote the gearbox backlash in arc minute. 1 arc minute is equal to 1 divided by 60 degree. So the backlash is the good or bad? The answer is a minimum possible amount of backlash is the good, at which the gearbox can run efficiently without compromising in their performance and life. And the second term we should understand is the gearbox maximum torque capacity. The torque capacity means the maximum torque that gearbox can handle, and it's depend on the gear material, the gear size, or we can say the teeth size, and the load distribution. So what does mean of load distribution? So let's say if the load is transferring from single gear to the single gear, the total load is coming on a single tooth at a time, means the load is not being distributed. And for an example, in case of Planetary gearbox, there is the load being transferred by the multiple number of gears at the same time. So the Planetary gearbox can handle a large amount of torque in the same size of the Spur gearbox. The first disadvantage of a Spur gearbox is the gear teeth strength. So in order to transfer the high torque at the high torque ratio, we need the large size of the Spur gear. And large size of Spur gear lead to large backlash, means inaccurate motion, less precise motion. So we use the Spur gearbox in non-precise applications, like in construction equipments, farming equipments, general juicers machine. Also, a Spur gearbox does vibration and make noise at the high load. And to overcome the low strength of teeth and the noise, we can use helical gears. Also, using a helical gearbox can reduce the backlash and improve the motion accuracy, smoothness, and reduce the noise. And the backlash we get in typical helical gearbox is approximately 15 arc minute for moderate gear ratio, The moderate gear ratio is between 5 to 20. But also keep in mind, the backlash is not only depend on the gearbox type. It's also depend on size of gearbox, number of stage of gearbox, and how precisely gear are manufactured. And top of that, how gear are assembled, the gear assembly process. So always check backlash for a gearbox specific model in their manufacturer catalog. But with the simple helical gearbox, we cannot solve all the disadvantage of a Spur gearbox. We still cannot achieve the high gear ratio with helical gearbox. So we use the worm gearbox. The worm gearbox has a screw interlock with a gear, and a worm gearbox have some unique features. The first feature is the self-locking. Because of their unique screw gear design, we rotate the screw, the input shaft of the gearbox, and gears rotate the output shaft of the gearbox. But we cannot rotate vice versa. We cannot rotate the gear because the screw will not rotate. And because of this feature, we use the worm gearbox in lifting and hoist application to avoid the accident on failure of motor or on motor power cut, electricity power cut. And the second unique feature of worm gearbox is we can achieve the highest gear ratio within a limited size. Because in worm gearbox, we can increase the gear ratio not only by changing the gear size. We can also increase the gear ratio significantly by reducing the gear lead size. And I have seen in a catalog the maximum gear ratio was 3200. Means if we will add this gearbox with a motor, and if the motor is taking 3200 rotation, the output speed will be 1 rotation. And this is why this gearbox is the one of the most popular industrial gearbox. And we can use this gearbox in almost all type of general application where we need the high gear ratio. And the backlash we get in a commercial helical worm gear is between 10 to 30 arc minute. And this is a limitation of worm gearbox. Worm gearbox need backlash compensation to run efficiently because of their screw and gear design. And a simple worm gearbox transfers the power in right angle direction because of their basic design. And there is one more gearbox which can transfer the drive at right angle, Bevel gearbox. But we cannot achieve the high gear ratio as compared to worm gearbox. Maximum gear ratio we can get is the 60 to 70. 1:60 to 1:70. Also, the Bevel gearbox cannot provide self-locking feature, but there is some advantage of Bevel gearbox over worm gearbox. Like in Bevel gearbox, we can get the less backlash, like 5 to 10 arc minute. Also, Bevel gearbox is more efficient, more smooth, and can transfer more power at high speed. But their design is little complex, so it's costly and need maintenance. And we also use this gearbox just to change the direction of shaft at right angle. And as far as we have discussed the gearboxes, they are either parallel shaft or right angle shaft. But what if we need inline power transmission gearbox? Then our first option would be Planetary gearbox. Also, Planetary gearbox are available in right angle direction. By including a Bevel gear, we can get almost all three types of orientation in each type of gearbox just by including a Bevel gear. And in Planetary gearbox, the gears are arranged in sun and planet arrangement, as we have a study in university. And this gearbox is known as high torque density gearbox. This gearbox can transfer the high torque in very compact size, because in sun and planet arrangement the load is well distributed within multiple gears. Also, we achieve the high precision and minimal backlash up to 3 arc minute. Top of that, we can also achieve the high gear ratio like 1:100. less noise, high stable, compact size, high efficiency, more than 90%, where other gearbox gives the efficiency between 80 to 90%. High efficiency means the low loss of power, less loss of power. So should we use the Planetary gearbox in every application? Because the Planetary gearbox is good in all aspects. And you know the answer is no. Because the Planetary gearbox cost is also very high. Because the Planetary gearbox has complex design. So let's conclude it as a mechanical design engineer how we should make the selection of gearbox step by step. And the first step is we have to define our system acceptable backlash, because the backlash will define our main category of the gearbox, either a precision gearbox or a normal gearbox. For example, in a belt conveyor, a high amount of backlash is acceptable, so we can use any normal precise gearbox like simple helical gearbox, worm gearbox or helical worm gearbox. But for example, in case of ball screw servo motor based linear actuator, the high backlash will destroy your expectation of high precision. So we have to choose the Planetary gearbox or any other type of precision gearbox, cycloidal gearbox and strain wave gearbox for high precision application. But their applications are limited because there is a huge cost difference between precision gearbox and normal gearbox. So be careful. And the second step is to calculate the gear ratio. And we calculate the required gearbox ratio using this formula. The required speed of the machine divided by selected motor speed. If the required gear ratio is between 1:5 or 1:20, there is multiple options for the gearbox. Like for normal precise application, we can use helical gearbox, worm gearbox and Bevel gearbox. And for high precision application, we can use Planetary gearbox. But if some specific feature is needed, then we have to stick with one of the gearbox. Like if self-locking feature is needed, then go with the worm gearbox. But if the inline gear drive is needed, we cannot go with the worm gear. We have to go with the helical or Planetary gearbox. If the compact size of gearbox is required at high gear ratio, go with Planetary gearbox. But if the huge gear ratio is required, like 1:1000, worm gearbox will save you. And we mostly use reduction gearbox. We always consider the gearbox to reduce the speed and increase the torque. I have never used the gearbox to increase the output speed of motor. But in some cases, like wind turbine, blade speed is slow, but the torque is huge. So here we use the gearbox to increase the speed to match the generator required speed for efficient power generation. And this is why the gearboxes is the one of the most important elements in mechanical engineering. Also, a most important thing in gearbox selection is the frame size. The gearbox mounting frame size should be compatible with the motor mounting frame size. If the selected gearbox frame size will not match with the motor frame size, you may have to add some coupling or mounting between plates to assemble the gearbox and the motor. So always try to select the gearbox type and their size according to the motor size and motor type. Like do not try the worm gearbox with the servo motor. With servo motor, we generally use Planetary gearbox to keep intact the high precision motion. Or if the manufacturer can provide you the gearbox with the motor, gear motor, combination of the motor with the gearbox at a better price, must go with the gear motor. I hope I have covered all the situation related to the gearbox selection. If I am missing something, please let me know in comment. I will definitely try to answer you. Thank you so much for the watching.